All right, in the practice book on page 9 and 10, forgot to start recording, so we are up to part D. A was false, B was true, C was true, and the work is shown here. On D, we've got 4 to the 4th times 4 squared is equal to 4 to the 6th. 4 to the 6th is already in simplest form, so we're going to use the product rule to combine 4 to the 4th and 4 squared. Product rule says keep the base, add the exponents. When you add 4 plus 2, you get 4 to the 6th. Since 4 to the 6th and 4 to the 6th is the same, we mark this one as true. On E, you've got 13 to the negative 4 divided by 13 to the positive 4, and they want to know if it is equal to 13 to the 0. I know that your instincts are telling you negative 4 and positive 4 makes 0, but that is not true. Okay, that is not true. 13 to the 0 is in simplest form. 13 to the negative 4 divided by 13 to the positive 4 is the quotient rule. You keep the 13, you subtract those exponents. Negative 4 in the numerator minus the positive 4 from the denominator makes 13 to the negative 8. 13 to the 0 and 13 to the negative 8 are not equal. This one is false. On F, 2 to the 3rd times 8 to the 3rd to the 0 is equal to 16 to the 9th. You're going to want to start in that parentheses and start simplifying and combining to get that 16, but that's not the case. Everything in the parentheses with a 0 exponent becomes just 1. 1 and 16 to the 9th are definitely not equal, so it is false. 2. Tyler simplified the expression 5 to the 4th times 5 to the negative 9. All of his work except his answer is shown below. Original question, 5 to the 4th times 5 to the negative 9 is equal to, what he's done is he's kept his base and he is adding his exponents, which is correct. So 5 to the 4 plus negative 9 becomes 5 to the negative 5. Now he's not done because we're not allowed to leave a negative exponent. To make a negative exponent positive, we're going to take that 5 to the negative 5, we're going to make it a fraction over 1. Then when we flip the reciprocal, our negative 5 exponent becomes a positive 5. The correct answer here is B. Number 3. On your quiz, this would be the same as a 3-part question because it is 3 totally different questions. They're giving us 3 expressions they want us to simplify. The first one says 10 to the 4th times 10 to the negative 2. This is the product rule. You keep the base, 10. You add the exponents, 4 plus negative 2. 4 plus negative 2 is 2. So the answer here would be 10 squared. The second one is 5 to the 4th times 7 to the 4th. This is like exponents with different bases. This is where we keep the exponent the same and we multiply those bases. 5 times 7 is 35 to the 4th. The last one is a bigger combination. We've got those unlike bases with like exponents, and then we have that power rule on the outside. Start on the inside of that parentheses. Let's do 2 times 4 makes 8 to the 7th, because they both had an exponent of 7. And then we have that 3 still sitting on the outside of there. Now we're going to use that power rule, 8 to the 7 to the 3. We keep the 8 and we multiply 7 times 3 to get 21. And then that would be your final answer there. Number 4, simplify 32 to the negative 1 over 32 to the positive 6 and write your answer with a positive exponent. Now, I'll go ahead and tell you there is more than one correct way to do this. I'm going to start off with the quotient rule. You've got 32 to the negative 1 over 32 to the positive 6. The quotient rule says since the bases are the same, we keep the base, 32, we subtract the exponents, negative 1 minus positive 6. That gets rid of the 32, the 6 copies of 32 in the denominator. We moved them to the top. That's going to give me 32 to the negative 1 minus 6 is negative 7. I cannot leave a negative exponent. Put it back in that fraction form, flip the reciprocal, and the answer is 1 over 32 to the positive 7. Questions? Number 5. Write 9 to the 6th as a power with a base of 3. The base is 9. Okay, we're not worried about the exponent, we're worried about the base. They want to change a base of 9 to a base of 3. So just take the 6 that the 9 already has and sit it off to the side. Now, 3 and 9 are related. I can use 3 to get 9. 3 times 3 makes 9. 3 times 3 is equivalent to 9, so the 9 has been taken out, the 3 times 3 put in. As an exponent, that would be 3 squared to the 6th. Now we use the power rule, and we get 3 to the 2 times 6, which is 12. So 9 to the 6th is the same as 3 to the 12th. You have to look for that relationship. Questions there? Last question. Which expression is equivalent to 3 to the 4th times 5 to the 4th to the negative 3? Now you could start this in many different places. You could start with that negative exponent and make it positive. You could distribute the negative exponent and go from there. Or you could start working inside the parentheses, which is where I'm going to start. I've got different bases with matching exponents. So I'm going to multiply the base. 3 times 5 makes 15. And I'll keep that exponent, which was 4. Now the negative 3 is still sitting out there on the outside waiting. I'm going to go ahead and use the power rule. 15 to the 4 times negative 3 gives me 15 to the negative 12. Now I have to make that negative 12 positive. I'll make it a fraction. I flip the reciprocal. And I've got 15 to the positive 12 on the bottom. The answer here is C. Tanya chose B as the correct answer. How did she get that answer? She came up with the 15, but best I can tell is she took 4 times 4 and multiplied it by that negative 3. So she has multiplied all 3 exponents, which was not correct.